Okay, chapter 5.3 is about solving rate problems. We've been working with rates and ratios, and there's a special one that we're going to talk about today, and we may talk about some others, but we're going to start with this idea. That's kind of the distance formula. This is common in physics and algebra and other places. D equals RT. And this is just distance equals rate, which is kind of like speed, times time. Okay, so for instance, if we know that we're traveling at 60 miles per 1 hour, and we multiply that by 3 hours, that's our time. Our rate is our speed, 60 miles per hour. We multiply that by 3 hours. We can write that like a fraction if we want to. And that's what our distance is. Distance equals rate times time. If we go ahead and multiply this out, I can see that 60 miles per 1 hour multiplied by 3 hours, the hours cancel out, leaving us only with miles. See, this M stands for miles per hour. 60 times 3. And 6 times 3 is 18. So 60 times 3 is 180 miles. And you know that if you're traveling 60 miles per hour and you travel for 1 hour, you're going to go 60 miles. 60 miles per hour for 1 hour. And if you traveled another 60 miles at 60 miles an hour for 1 more hour, it'd be another 60 miles. And if you went for another hour, it would be another 60 miles. And 60 plus 60 plus 60 is equal to 180 miles. So we can see why this works. 160 miles times 3. Okay? So that's kind of just a simple, this is how it works. We have D equals RT. Now occasionally they'll do this a different way. If you need to know what the speed is, if you're trying to figure out what the rate is, then they do another one. Rate is D divided by T. The distance divided by time equals rate. And you could kind of see that. For instance, D equals R times T. If I did D divided by T, it would give me rate. Let me show you a quick example. You know this works. Say that 10 is equal to 5 times 2. So if I wanted to know what 5 was, or if I wanted to do a division problem, 10 divided by 2 equals 5. And that's all we did. Another way to do it would be 10 divided by 5 equals 2. These are all related multiplication division problems. And this is just using letters to do the same thing. Distance equals rate times time. So rate equals distance divided by t. This is like that if we had distance equals rate times time, then I took my distance and I put the t over here, this 2 down on the bottom, it would leave me with 5, which is the rate. So this is sort of like distance over 2 is the time. Distance over time equals the rate. Distance over time equals the rate. I hope you can see what we did there. This is just an example. I know this is the one we start with, and this is the formula that we move to. And these really are the same formulas. They're just written different ways. It depends on whether we're trying to find distance or whether we're trying to find rate. And technically, I could try to find time. Time would be distance divided by rate. That's what this one looks like. Time is 2, so this is the time equals distance divided by rate. Distance is 10, rate is 5, so 10 divided by 5 is 2. So if we wanted a third equation, this would be it. And it might be that you want to take a second and pause the video and write these 3 down. 2 of them are listed on page 204 in your book, and if you're following along with your book, this will help. Okay, so the first one, finding a distance. It gives us an example of a peregrine falcon it can dive at a speed of 80 meters per second. Okay, how fast can it dive in 4 seconds? So we have the rate of 80 meters over 1 second. We're going to multiply this by 4 seconds. Okay, so 80 meters in 1 second, we're going to multiply times 4 seconds. This is really the distance over the rate times this is the rate. Excuse me. I might have to cut that out of the video. This whole section is the rate times the time. This is rate. Actually, we usually do it with a little r. Make sure we do it that way. That's the rate, 80 meters per second. 4 seconds is the time, and equals the distance. So this one's written backwards. Distance equals rate times time is the same as rate times time equals distance. We'll get used to these formulas. We get just used to using them. If I write this as a fraction, my seconds cross out. 80 times 4. Well, 8 times 4 is 32. Add that 0 and makes 320. So 4 times 80 is 320. We've gotten rid of the seconds. That leaves us with meters. So the distance should be in meters. That makes sense. Rate times time equals distance. 80 meters per second times 4 seconds equals 320 meters. That makes sense, I'm pretty sure. Example number 2, finding a speed. So we're going to use rate equals distance divided by time. That's the second formula I gave you. Rate equals distance divided by time. And you just kind of maybe potentially just have to learn these because they show up over and over again. If you understand it, or if you know distance equals rate times time, you can figure out all the others. This is the main one. But they want us to use this one as well, which is a related multiplication problem. And they say a great white shark swims 90 feet in 2.5 seconds. What is its speed? So the distance is 90 feet. So we're going to write 90. Ooh, we can write better than that. 90 feet in 2.5 seconds. Oops, 2.5 seconds equals our rate. So we can write the formula like this, and then we go ahead and we use potentially we can use a calculator or long division to solve this. So 90 divided by 2.5, we have to change that to a unit rate, which is something that we did before. We change it to 1 second. That's basically what we're doing. But we could just also punch in the calculator 90 divided by 2.5, because that's really what we do. To get from 2.5 to 1, we have to divide by 2.5. So to get the same thing on the other ratio over here is 90 divided by 2.5. We have to do them both by 2.5. So this shows you that it's 90 divided by 2.5 because a fraction is a division sign. I think you guys know that. You should. So you can punch in 90 divided by 2.5 on your calculator, or you can do 2.5 into 90 and move the decimal so that it's 900. And 25 goes into 93 times. That's 75. That leaves 15. Bring down the 0. That's 150. And 25 goes into 150. Well, there's 4 quarters in a dollar, and plus 2 more for 50 cents. So 6 times 5 is 30. 6 times 2 is 12. 13, 14, 15. Works. So 36 times. So 90 feet in 2.5 seconds is 36 feet per second. 36 feet per second. And it's okay to do to use a calculator. You don't have to. I didn't. You can do it like me. That's the better way to do it, but it takes more time. This is a calculator exercise. You have to understand how ratios work, and then you have to understand how to use a calculator. After that, it's okay for you to use one. So it's 90 over 2.5 seconds. So if we punch in on our calculator, let's clear it out. 90 divided by 2.5. Let's just make sure. And it's 36. Now, I kind of like to do it on paper because it makes me, well, that's not what it is. That's a song we were looking at. Here we go. I like to do it on paper. It makes me understand exactly what's happening. Okay. But that's how it works. One final problem. We'll just look around and how high does a hot air balloon rise in 15 seconds? So, use the distance formula. This is example number 3. Now, there's a picture of a balloon that says rises 9 meters in a vertical direction every 3 seconds. So this is kind of our ratio, 9 meters in 3 seconds. It goes up. And it wants to know how high it rises in 15 seconds. So we'll write a ratio, 9 meters over 3 seconds. And we can say, well, how much is that in, because it says, the question asks, how much is it in 15 seconds? And we can immediately say, well, that's pretty easy. 3 times 5 is 15. So 9 times 5 should give us a total for how many feet it rises in 15 seconds. And that 9 times 5 is 45. So 45 meters in 15 seconds should be our answer. And you can see how we got that answer. The book actually gives you a different way. They start with this 9 meters in 3 seconds. And they find a unit rate, which is out of 1 second, which is divided by 3. So they divide it by 3. And 9 divided by 3 is 3. So it's up 3 meters every 1 second. This is a unit rate. So if you know it's up 3 meters every 1 second, distance equals rate times time. So our rate is 3 meters every 1 second. And we're going to multiply by 15 seconds. Okay? And over 1 so that our fractions look the same. Okay, and this is going to equal our distance. Now this is using the formula a little better. I didn't actually use the formula here. This is a good way to do it. This is the way we might have done it in the last lesson, but this is using the distance formula. So basically it's just 15 times 3. The seconds cancel. So distance equals 15 times 3 is 45 meters. And that's what we got, 45 meters in 15 seconds. Distance equals 45 meters. That's what they're looking for. Okay? All right. Good luck with this assignment. We'll work on it in class tomorrow.